picking back up in lesson 3.5. And I don't know what you guys remember from Friday. Probably not a whole lot, okay? If we back up to Friday real quick, we were looking at factoring, and then we looked at the zeros. And if you recall, we tested. We tested in between the zeros to see where our graph was positive or negative, and then we were able to draw our graph crossing through the zeros in appropriate positive or negative, okay? So again, this whole lesson 3.5 is, exploring what the graphs look like, what we know about them. So here in this next part, we're looking at zeros again, but we're talking about something called multiplicity. And the idea of multiplicity is, if you look at some of these factors in these examples here, some of them have powers. So they have a multiplicity greater than 1. A typical factor just has a power of 1, and if that's the case, just like what you saw in this previous page, the graph goes through the x-axis there, nothing abnormal. When that multiplicity changes, when that power changes, my graph does different things, okay? My graph could still go through, but it could kind of curve its way through, or my graph might not go through at all. It might touch it and go back down or back up to where it came from. So this is what multiplicity is. So officially, the multiplicity of a zero of a polynomial function is the number of times the related linear factor is repeated in the factored form. Multiplicity of a zero is determined by the power of the linear factor. So when we talk about multiplicity, it's the power of the factor. Okay, so whatever that power is, if you're asked the multiplicity, it's going to be the number of the power, okay? Now, what it tells us, if that power, that multiplicity, is an odd number, then my graph will cross the x-axis. If it's a higher power, it might kind of curve its way through the x-axis, but it's going to cross somehow or another. If that multiplicity, that power on the factor, is even, then my graph isn't going to cross at all. It's going to go up, touch the x-axis, and come back down. Or if it's already above, it's going to go down, touch the x-axis, and go back up. So in that case, the graph will touch the x-axis, and it has a turning point, means it turns around. Okay? Now, so what we're being asked to do here. It says describe the behavior of the graph of the function at each of its zeros. So we need to find all the zeros. Okay, it's in factored form, so that's the easy part. We need to state the multiplicities, which is the power of the linear factors. And then we need to describe what's it going to do at each of those. Is it going to cross the x-axis, or is it just going to touch the x-axis? So, officially, how do we find our zeros? Yeah, okay. Officially, it set the whole equation equal to 0, right? But then what happens once we set that whole equation equal to 0? We have individual factors we can set equal to 0. So we're going to start, and I don't have a ton of workspace here, so I'm going to jump right into, I'm going to set each of my factors equal to 0. My first factor, don't overlook it. What is that first factor? X. We're going to set x equal to 0. We're going to set x plus 4 equal to 0. And I am spacing this out on purpose. In fact, I might even space it out a little bit more. And what's our other factor? X minus 1 equal to 0. Okay? Those right there are each of the factors. Now, in order to solve them and find our zeros, basic solving, yes? We know one of our zeros is going to be x equals 0. For x plus 4, we know x is going to equal negative 4. And for x minus 1, we know x is going to equal 1. So those right there are my zeros. That row of values I just found are my zeros. Okay. The next row of information I'm going to put on here is the multiplicity. Now, again, multiplicity of a zero is determined by the power of the linear factor. I'm going to start over here because I think it's the more obvious one. When we took the factor x minus 1 and set it equal to 0, what was the power of that factor? X minus 1 in the original function had a power of what? 4. So it has a multiplicity of 4. And on my notes, I just wrote it as m equals 4. Okay? It's the power from that factor. What about, oh gosh, that's not what was supposed to happen. Okay, what about this next one here? X equals negative 4 came from the factor x plus 4. What's the power on that linear factor? What if I say, what's the invisible power on that linear factor? There's an invisible 1 there, yes? So the x equals negative 4 has a multiplicity of 1. And what about x equals 0? That came from where? Came from x. What's the power on that factor? Invisible 1 again, yes? So my multiplicities, you can't just say your multiplicities are 1, 1, and 4. You have to pair them with the specific zeros. Those are my multiplicities. Now, what we need to state is based on those multiplicities, does my graph cross or touch the x-axis? So what do we know about 1? Is a multiplicity of 1 odd or even? 1 is an odd number, yes? So that means my graph is going to cross the x-axis, and so it's going to cross the x-axis at x equals 0. So I'm going to write here that it crosses the x-axis, and that's because 1 is odd. Because it's odd, we know it crosses. Okay. What about the 0 of x equals negative 4? It has a multiplicity of 1. What do we know about the number 1? It is also odd. And if it's odd, what's it going to tell my graph to do? It's going to tell the graph to cross the x-axis. And it's going to cross the x-axis at x equals negative 4. Okay. And lastly, what about the multiplicity of 4? What do you know about the number 4? It's even. What do my directions say if the multiplicity is even? The graph is going to touch the x-axis. So here, I'm going to state that my graph is going to, or that it touches the x-axis. Okay. And I think, let's see, describe the behavior. Officially, doing all of this right here, stating our zeros, our multiplicities, and the behavior, whether it crosses or touches the x-axis, is what it asks us to do. Okay? In Savvis, that's like a lot of, you might fill in the zeros, but other than that, it's a lot of like drop-down menu type stuff, if I recall, or multiple choice, one of the two. Okay? Now, you're not being asked to do this, but I'm going to show, just so you can get an idea of what this looks like as a graph. What do we have? Zeros. I'm just going to sketch a small little graph over here. And again, it's just so you guys can see the difference of touch and cross. Okay. We know we had zeros at negative 4, 0, and 1, yes? That was the first thing we found. We had zeros at 0, negative 4, and 1. So we know there's points there. Now, if we look at these, at negative 4, my graph crosses. At 0, my graph crosses. But at 1, my graph touches. And so what we're looking at is, and we start up above, we cross, we touch, and go back up. That's the basic idea of just the general shape of what this graph would look like. Okay? Now, I could set up a number line. Okay, we're not going to, but we could set up a number line like what we did on Friday, and we could test each section. You'd come up with a positive, negative, positive, positive. You'd have two positive sections in a row. Okay? We could also talk in behavior. If I multiply this all together, right here we'd have x to the fourth, another x to the first, another x to the first. That would be a total of x to the sixth. And x to the sixth, if you remember in behavior, is even. And even is up and up if it is a positive x to the sixth. So there's another reason I know it's up and up. And again, I'm not quite expecting you guys to put all that together yet. That's a lot. But my point is that's all stuff you can figure out with what we know. Okay? Okay, questions on this? I really spent a lot of time going into that, but it's important stuff. Okay, so let's look at B. We need to start off finding our zeros, which means we're going to set each factor equal to 0. Sorry, I felt like I needed a line across there to separate all this. So set each factor equal to 0. We have a factor of x squared plus 9 equals 0. X minus 1 equals 0. And x plus 2 equals 0. Okay. What about this x squared plus 9 equals 0? Officially, what do we do? Well, since it's x squared plus 9, I wouldn't say factor. It's already as factors that can go, but if you square root after, I'm going to, so get x squared by itself. So subtract the 9 over. X squared equals negative 9. What happens when we square root? What's the square root of negative 9? Yeah, square root of 9 is 3. Yes, we can hopefully all agree to that. Square root of a negative 9 is 3i. And then because we're in an equation setting, officially we need to say plus or minus 3i. Now, here's the deal. What do we know about 3i? Okay, it's imaginary. Are you going to see 3 plus or minus 3i on a graph? No. So for what we're doing, the purposes of what we're doing, this wouldn't matter. These are not real zeros. And so this one's going to end up not mattering. Does that make sense? It will x squared plus 9 can never equal 0. X squared can never be negative, so x squared plus 9 can never equal 0. So those, if you get a situation like that, we're not going to get any real zeros out there. You get imaginary zeros, but we're not talking about that today. Okay? Now, did you finish the other two? If x minus 1 equals 0, x equals 1. If x plus 2 equals 0, x equals negative 2. Yes? So those are your zeros. And I'm still going to set this up here. Okay. We also need to find our multiplicities. What's the multiplicity of x equals 1? You agree with her? 5, because there was a power of 5. So multiplicity of 5. What's the multiplicity on x equals negative 2? Had a power of 2, so multiplicity of 2, yes? Now, what's my graph going to do at each of those points? At x equals 1, what do we know about the multiplicity of 5? 5 is what? 5 is an odd number. And what's my graph going to do in an odd multiplicity? It's going to cross the x-axis. Now, I will say it's going to do something, it's still going to cross. I will say it's going to do something a little bit different just because it's a higher multiplicity. It's going to kind of curve as it crosses, but I'll show that. What about this one over here? Multiplicity of 2? 2 is even, and even tells me we're going to just touch the x-axis. We're not going to cross. Okay, so there, right there, you only have 2 zeros to talk about. We know one crosses, one touches. Okay, and again, as I said, these are zeros too, but they're not real, so we're not going to worry about them. Now, again, I'm going to kind of sketch the graph on here. Where are we at? X equals 1 and negative 2. So 1 and negative 2. So those are my zeros. So I know my graph is going to cross at 1 and negative 2. Makes sense? Now, let's start with negative 2. At negative 2, my graph is going to touch. So it's going to touch and turn around and go back where it came from. So either go back up or back down. At 1, we are going to cross, but it has a higher multiplicity, which means it's going to cross, but it's going to kind of curve as it crosses through, or flatten out. Now, let's see. Here's the easiest thing for me to do. I have x to the 5th here, x to the 2nd, so that's 7, plus we have 2 more. We have x to the 9th here. X to the 9th is either up and down or down and up. Because it's positive x to the 9th, where it's going to be down and up. Now, okay, what did we say we were doing at negative 2? We said we were going to touch. So at negative 2, so I'm going to go up to negative 2. I'm going to touch it and turn around, come back down. And then at 1, we said we're going to cross. But because it's a higher multiplicity, my graph kind of curves its way through there. So the higher the multiplicity, your graph will just kind of flatten out more at that crossing point. Okay? So it looks something like that. If you guys went and graphed these on a graphing calc there on Desmos or something, you get the similar shape. Okay? And that's all I'm trying to show you is the shape right here. Now, are you guys responsible for being able to graph these? No. If you're saying, whoa, that's a lot, can you handle what I boxed? That's what I need out of you right now. Okay, make sure you can handle what I boxed here. So finding the 0, the multiplicity, which is the power, and then does it cross or touch? Okay, now, I don't remember, could they maybe have you look at a graph and pick a graph in Savas? Possibly. I wouldn't be opposed to you guys being able to do a multiple choice scenario and pick the correct graph. But I'm not going to ask you to sketch this yourself yet. Okay? Okay. Let's flip to the back. We'll see how far we can get in this today. Okay, guys. On the back, we've got several examples to work through. And they ask us, what are all of the real and complex zeros of the polynomial function shown in the graph? Now, notice it says real and complex. Real, like if we go back to the last example we just did, real was the 1 and the negative 2, yes? Remember complex? Complex is the fancy number for the imaginary because complex is the form a plus bi. And so they're saying they want to know all the real and imaginary zeros. Okay? Now, zeros. Okay? Well, I'll come back to this here in a moment. As we look here, they give us an equation. They're giving us a snapshot of the graph. Okay? What do you physically see on this graph right now? What do we know about that graph? You can tell me 1, 0 for sure, no question about it. There's a 0 at 2, yes? Because we know right there my graph crosses the x-axis, right? So right there, we know a real 0. We know without doing any work that there is a 0 at x equals 2. Okay? Now, and I'm writing small because I have a lot of stuff to squeeze in this not big enough space here, just so you know. Okay, now, there's a 0 at x equals 2. Think backwards for me. What would that have been as a factor in the equation? X minus 2, right? Does that make sense? If you think back to like this right here, we had a factor of x plus 2. It gave me a 0 of x equals negative 2. So it's always just the opposite sign. Okay, so I need you to know there's a 0 at x equals 2. We also need to recognize that that is a factor of x minus 2. Okay? Now, there's some vocabulary over here that I threw in a box because I think it's helpful to point out. I've just used the vocabulary 0, yes? Okay. We knew it was a 0 because what did it do on the graph? It was an x-intercept, yes? Or in other words, the graph crosses. So statements that we can make here. The graph crosses the x-axis at 2. We can call it an x-intercept. We can call it a 0. The statement that could be made is f of 2 equals 0. So when we plug 2 into the equation, you're going to get 0 out. That's the ordered pair, 2, 0. And then the last one is that x minus 2, so if it's 2, x minus 2 is a factor. Okay? I use a lot of that vocabulary. And I use it kind of not necessarily interchangeably, but all connected. So you need to be familiar with all that vocabulary there. Okay. Now, back to this problem. We spotted one real 0, yes? Do you physically see any other zeros? Are there any other places my graph crosses the x-axis? No. So I only have one real 0. One real solution to this problem. How many solutions should I have to this problem? What's my highest power? 3. There are 3 zeros or solutions of some sort. The key is, if only one of them's real, what's that mean about the other 2? They're complex, they're imaginary. Okay? So, we need to find those 2. Okay, guys, we learned synthetic division last week, right? Last week, week before, I don't know, somewhere in there we learned synthetic division. We're going to use synthetic division to start us factoring this down, and then we'll solve. So, synthetic division. What number goes in my box? That's going to be the 2. Now, numbers next to the 2. What goes next to the 2? Those are my coefficients from the equation, yes? Make sure all place values are covered. So we have 1 from the x cubed, 1 from x squared, negative 3 from the x, and negative 6. Okay? We haven't forgotten synthetic division yet, have we? Okay. Drop the 1. 2 times 1 is 2. Add. 1 plus 2 is 3. Multiply. 2 times 3 is 6. Add. Negative 3 plus 6 is positive 3. And then multiply. 2 times 3 is 6. Negative 6 plus 6 is 0. I'm going to tell you guys, that is a huge checkpoint right there. If you get something other than 0, you made a mistake. How do I know it has to be a remainder of 0? Because I know 2 is a solution. I know 2 is a factor. So I have to get 0 there. Now, what does 133 represent? This first one was originally a what? X cubed. So when we do one row of division, what is this new one? This is now x what? X to the second, yes? So this 133 represents 1x to the second plus 3x plus 3. Yes? Remember that? That's how you put your answer back for a synthetic division problem. Now, that's one part of this that we know right now. We divided by this 2, yes? What did this 2 represent? It represented a factor of the x minus 2, yes? So right now, that's what my factored form is. We know the answer to x minus 2 equals 0. We know that's 2. We're done with that. We need to know x squared plus 3x plus 3 equals 0. So, x squared plus 3x plus 3 equals 0. Well, I'll ask the question because I always do. Does it factor? It's not going to factor. I can't, there aren't two numbers that are going to allow me to multiply to be 3 and add to be 3. And here's the deal, guys. If my other two zeros are imaginary, it's not going to factor. What's the backup plan to solving this when it doesn't factor? If we can't solve a quadratic through factoring, we learned something back in Unit 2 here. We relearned something. Quadratic formula. Folks, we're at that level in the game where quadratic formula never goes away. It's not a, oh, we learned it in this chapter, we're done with it. No, it's here. It randomly pops up into our business, and it's here today. So, you might want to have that blue paper by your side, or, you know what? Here's what I also say, guys. Google, Alexa, Siri, do they know the quadratic formula? You laugh, but they do. So, okay, guys. You're going to want that quadratic formula, yes? And I guess I did just see Henry writing it up top. I think I'm going to take that idea. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. I'm not saying you have to have it memorized, but my goodness, it's getting there. Okay, especially if you're continuing on into math, yes, you need to have it memorized 100%. Okay. I don't really have room to mess with asking about my ABCs, so hopefully we're good with ABCs now. So x equals negative b. b is 3, so I'm going to say negative 3 plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is 1, times c, which is 3, all over 2a, 2 times 1. Okay, negative 3 plus or minus. Okay, under my radical, 3 squared is 9, minus 4 times 1 times 3 is 12. 9 minus 12 is negative 3. So I have this fun square root of negative 3 all over 2. Take more steps if you need to. Now, officially, okay, first of all, square root of negative 3. What do we know about square root of negative 3? That is square root of negative 1 times square root of 3, which we write as I times the square root of 3. So I'm going to go ahead and also break this up. And I'm going to say negative 3 halves plus or minus I times the square root of 3 all over 2. And I went ahead and broke it up. They might require that in Savas. You might be able to leave it in this form and just change it. But here's the deal. Those are 2 zeros. Those are my complex zeros. What did we also already have? my real 0 of x equals 2. How many zeros do I have right there? Plus or minus counts for 2. And then there's this one, 3. How many zeros should I have? 3, because it was x to the third. Okay. We've got a lot to cover tomorrow. But I will say, in all honesty, this is the worst of the worst in this set, because B is very similar. C is similar again. Similar but different, but it's not any worse. So, okay. You can start looking at assignments a little bit, or you can wait. Either or. This homework will be due Wednesday. We will finish it up tomorrow.
We need Claire Huff to the high school.